Hello guys, so today we will see the P scale in VEX. We will see a different type of P scale, how we can achieve P scale and apply some variation on it using VEX. So this lecture is specifically made for using VEX. So let's dive into Houdini and see how we can do this. First, I will take a geonode and I will create one grid like here you can see, and then I will scatter few points here. Let's make the background as dark. Okay, and now to view this point as a sphere on display, either we can copy to point sphere, which will kindly make it a little bit heavy, or else we can also select display particle as disks, but it is a kind of 2D and it don't have any depth. So what we will do, if you have seen, whenever we add vellum grains, it will automatically add one attribute which display the point as a sphere. If we turn off this and this, you can see it has only points, and now it don't have any attribute. If I turn on this, you can see no. If I turn on this, you can see one detail attribute have been added, name GL sphere points. So this attribute is responsible to make the sphere point a sphere on the display. So first we will add one attribute, create node, and then first we will create Pscale attribute here, and the default value will be 0.1. I will add another attribute which will be same, name GL sphere point, and this attribute will be detail and integer, and the value will be 1. As you can see, now the point has been converted into spheres, but it is actually points only. It is just for visualization. So now we will see different types of P scale in VEX. So let's take attribute wrangle. Now we will see first uniform P scale. Okay, so uniform, you can see by the name only, uniform, which means there will be no variation at all. For that you can simply write at f@pscale into is equal to 0.2. So now it has been extremely small. If I write to here, then it will be since I already have Pscale here, which I created the default, I'm gonna multiply the uh, existing Pscale with the new value. Okay, so this is uniform one. If we want some randomization on the Pscale, then we can do some changes in the code. Take another attribute wrangle node and write this code here. So we gonna make three float variables. Minimum scale is equal to minimum scale, and we will copy this, paste it here, maximum scale, max scale, and we will, if we click on this sphere parameter button, it will create our two parameters. Now we will create one float variable in which we will use these two value, and we will create one p scale value. So write p scale, okay, random value is equal to, we will use a fit range function for this fit 01, and we will randomize it using point number. So for randomization we will use a random function, and here we don't have id attributes, so we will use point number here. And then here we will have to use what is the minimum and maximum value which we want to assign. So we have already created the float value here, so I'm gonna simply copy this min here and the max after the comma and close the bracket, put this here, and then we will at p scale into is equal to random value. Now since the value is 0, so the point have been gone. Now you can see it has been assigned randomly. If we want some seed value also, like we want to change the parameters, means we want some different seeds, so what we can do, we can create one more channel, name seed, and then we can multiply the seed over here, ptnum, and then let's create it. You can see we can change the seed value here. In this way you can assign a random p scale using this code. I will give all this I will give this file for free in the link which will be provided in the description. So okay, let's now we will see some animation using VEX. So for animation we gonna see, now we will see how to so this one is has been assigned randomly based on point number. Now we will see how to randomize p scale using noise in VEX. So first, for noise we need to create a few float parameters like noise scale and everything. So type float noise scale is equal to, this will be our noise scale value. I am directly writing the code here. You can also create spare parameters to have access for the slider controls, and then I will write another float noise value is equal to, now I will use noise function. So you can see here noise, there are two form of Perlin noise and the non-periodic noise. So the usage of this noise, for float we need float and the position. For vector noise also we will use same only. This is for 1D noise, and p scale is also a one dimensional value only, it is not a vector value, so we will use 1D noise. So we wanna grab the position of the current point, and we will use this noise scale. We will fit this value on a minimum and maximum value. So float scale is equal to fit 01. So we're gonna use this noise value here, comma, minimum p scale, maximum p scale. Let's close the bracket and let's assign p scale into is equal to at scale. So now you can see this. If I also add time, then you can see it is animating. So first, currently I have let's remove this for the constant value, and now here if I increase the value, you can see like 10, 5. If I decrease the scale, then let's mm, create one channel for better control. You can see this how the scale works. And now if I add time here, then you can see how this works. You can see it is the time is working, but it is extremely slow. Since it is dependent on this, if I add plus, then it will work on its own. It won't be dependent on the noise scale value. As you can see, this since it is a 1D noise, it will go only on one direction. Okay, cool. So now we will see how to create a wave like P scale, like sine waves. Have you seen the sine wave parameters? I will show you. Wait a minute. So this is the sine wave. So how the sine wave work? Like it will go in positive, then it will go in negative, and it will have the constant graph. As you can see, the distance between one wave and the other wave is constant. It don't have a noise kind of thing. So how to create that using VEX? So let's create another attribute wrangle, and here we will need a few 3 4 float values. So let's create it. First will be our frequency. Frequency. Second will be amplitude. Third will be offset float. Offset is equal to CHF. So let's create all these parameters here. Now we need time as well. So let's create float time is equal to at time into so our time will be time multiplied by frequency. Now we want to create waves. So for the wave like creation, we will gonna use this sine function. So sine function require two value. First one is time and the second one is amplitude. So here we already have given amplitude and time. So let's create float wave is equal to sine here we're gonna use time bracket close multiply by amplitude plus offset. We're gonna add few offset as well, and now we will multiply our p scale with the wave. You can see it, there is point but it is not visible since the p scale value is 0 totally. So let's add frequency of offset few. Frequency, let's add. So this frequency will control the speed. If I slow it down, then you can see it is animating very slow. If I increase it, then it will be like uh, on off kind of thing. So in this way you can create a wave like this. So one thing you can see, this is going in negative direction as well. If you want a sine wave but it will only go in positive direction only, then what you can do, you can use absolute function here. If I will duplicate it and I will just write absolute and sine, then you can see this is not going in negative direction, it is only going in upward like this. I don't have paint, I guess. Yeah, I have. It is going only like this, and the older one, mm, this one is going like this. Okay, cool. Now we will see few other method as well, which is very useful if we create some snow kind of thing or particle, and some particle are coming extremely close to the camera, or we need few particles which are far away from camera and we want its size to be bigger as compared to the closer one, then we can use those VEX also. So let's dive into that. First I'm gonna create a grid and then point velocity for some velocity, and I will add some noise. And then I will add pop network. So let's add delete the point based on the age, so it will have something like this. Let's add some drag, pop drag, and around point 2. Let's add a ground here as well. Cool. So now this is our particle sim. Now we need to Suppose if we want to p scale it based on its speed, then how we can do it? So there are few method. First, let's again copy this attribute create node and assign it here. So we will have this, and also let's only import our pop. So this is our default p scale. Now we need to p scale it based on its speed. So what we can do, we can use, let's create few parameter chf minval, copy this, paste it here, maxwell, max velocity. Then we will, since these velocities are vector field and we can't use that as a for the p scale, so we need to convert the length of the velocity into a float. So to do that, what we can do, we can create a float uh, vel is equal to length of the velocity, length of velocity. Yeah. Now let's create the parameter, and the minimum velocity will be 0 and the maximum, let's see what is the maximum value. Hide all attribute v, and the maximum is 50. So 15, 15, yeah, 15, the maximum is 15. Now what we can do, we can combine all that into a fit value. So scale well is equal to fit, we will not use fit 01, we will use fit value here. So we need the well, we will use the well, and since we have the length calculated here, and we need the minimum and maximum length here. So you can see we have already created we have already created two minimum and maximum channel. So let's paste it here, and then we will need to define minimum and maximum p scale. So min p scale comma chf max p scale. Let's create the channel, and now we can multiply the p scale into is equal to scale well. So now it will be 0 only. So now if you see on the starting, based on the velocity, it will scale the p scale sphere points, and then scale it down. You can see here wherever the piece velocity is faster, the spheres are too big here, and however it gets slow due to the drag force, the scale value is getting smaller. If I change this to 0 minimum p scale, okay. So in this way you can animate the p scale using the incoming velocity. Now if we want to change the p scale based on distance of another point or object, how we can do that. So to do that, take another attribute angle node, and here we will create a add node which will be our ref reference point. So this will be our reference point. So what we need to do, I will show you what I'm trying to do. So our point is somewhere here, and we want to blend the p scale based on each distance. So what will it will do, it will have the p scale value of 1 here and 0 here. So like it will have something like this, and all this value will be 0, like the minimum value which we will define. So let's do it. How we can do? First, we need the point to get stored on this attribute triangle. So to do that, target, we will use the point function. First one will be why it is coming error? Oh, not, it should be 0, not O. So one is our first in which our add node is connected. So this is 0, 1, 2, 3. So I have written one here, and we need its a position. So I have written a position, and I want it to be assigned to the point number of 0. So now I want to create maximum distance, how far the value will get blend. So max dist is equal to chf. Now we need to calculate the distance between the current position of the point and this point. So to do that, we need to use the distance function. So float distance is equal to, we're gonna use distance function, current position, and the target. Let's add the comma here. Now it will calculate the distance automatically. Now we need blend, how far the values should get blend. For that we will clamp the value. So like we gonna use the blend, and we will clamp it based on the distance divide by our how far the values should get blend. So our the far value is our max distance. We will divide it, and we will clamp between 0 to 1. Cool. And now we will fit these values calculated values using fit range. So our float scale will be fit 0 1. We will use the blend. Now the CHF min P scale comma CHF max P scale. Let's create all this value, and now we will at P scale is equal to into is equal to scale. So now our maximum distance, let's assume 5, minimum will be 0.5, maximum will be 10. So now you can see this is getting blended. If I increase this distance, you can see how the values are getting blended. Even though I can reduce the minimum P scale also, you can see how smoothly it is getting blend. And also we can create like this, like if we have some torch fire kind of thing like this. Suppose I have a torch here, and I want only few particles should be visible in the dark room. So we can use this, and also we can add some noise here also, but I you can experiment it. Now what if we need to scale the points based on its age? So to do that, since we already have age, but the age is not the normalized age, it is value is going above 1. So to fix this, we need to write few code again. So first we will create again float max age is equal to, so our maximum age which we have defined here is 2, and we have a variation of 0.2 as well. So we will give 2.2, and now we want to normalize the age. So normal age is equal to, so for the normalize function we're gonna divide the age with the maximum age, the current age with the maximum age. So our age which is coming from here only to the max age. Now if I define this normal age as a float attribute, then age n is equal to normal age. You can see age n, you can see this, it is going maximum to 0.9 only. And if you are worrying this value is going 6, but if you see here it is e negative 5. E negative 5 means it is the power of 10 with the value negative 5. So it is around, if I calculate it using a calculator, then so the this value is around 0.000061, so it is extremely less. Now what we need to do, we need to fit this value into a minimum and maximum scale. So float scale is equal to fit 0 1, normal age comma minimum and maximum point 1 and 2. So now at p scale into is equal to scale. So now you can see at the bond it is around 0.5, even though I can make it 0 as well, so it will be like this. And we can also uh, reverse it as well. We can keep 2 here and 0 here, so it will smoothly get dyed. Okay, we can 0.5 as well, like this. Thank you guys for watching. See you in the next tutorial. Also don't forget to support me on Patreon. And this is my first time doing tutorial with my own voice. If there is anything, then please forgive me. And also if there is any mistake, kindly give me some feedback so I will improve it in the next tutorial. Thank you guys. See you in the next tutorial. Bye bye.